All right, welcome back. My name is Nico Carver. This is a part 2 to my video about the Blue Horsehead Nebula, but it's also broadly applicable to anyone wanting to process reflection nebulae with free software. And I will be using the latest versions of some free software out there that are popular for processing deep sky astrophotography. But the first step is we need to get our data to the computer here. And if you have an ASI Air, you could power it up, plug it in with a USB-C to A cable to your computer, and all of the folders, the lights, the darks, the bias, the flats will already be there, and you can just transfer them off to your computer. If you captured on a DSLR, or if you backed up your data to a DSLR with the ASI Air, you can also alternatively just transfer your data off the SD card. But before I put the SD card into the computer, I like to just review my data right here on the DSLR screen. And it's very quick to do. When you go into playback mode, you can zoom out and you can just quickly scroll through your files. And you can see these are the darks from my last project. And then this is where the lights start for this one. And what I want to note is when I get to the start of the lights range, I'm going to look at the file number. So you can see it's 1649, and I'm going to write that down as the start of the lights range. So then I know, okay, all of these are going to be lights. And if you see anything unusual as you're scrolling through, like this frame looks unusual, you can just examine it right here on the DSLR screen. And that's pretty interesting. What that is it's an out of focus firefly getting in front of my lens. We have tons of fireflies this time of year, and they do photobomb some of my shots. Now, you could reject that frame, but there's no reason to. If you're taking dozens and dozens of pictures of lights, you don't have to reject frames with satellite trails or even big out of focus fireflies like this, because the rejection algorithm that's used in stacking will do it automatically. But if you saw something even more unusual, like out of focus stars or trailed stars, those are things you might want to note to reject out of hand. But I'm pretty confident all this stuff is in focus. And the other thing to look for as you're going through here are clouds. And that can be very easy to see as you're scrolling through. If you see clouds come in, that's a range you may want to reject. The other thing here is I get towards the end, look what happens. The trees, the trees come into my shot. So the ASI Air was still guiding on the stars here because there were enough stars to guide on, but it didn't know these trees were coming in. So I don't want to include those. So I'm going to stop my lights range right here, right where the trees are just coming into the corner. So I'm going to stop at 1715, okay? So that's the end of my lights range. And then I can keep scrolling down here and see I started my darks right here at 1751. So I'll note that as the start of the darks range, and then keep going through here and just note down all of the ranges. So the end of the darks range is at 1770, and the start of the flats range is at 1771. Okay, once you've noted all of this down, you can turn off the camera and take out the SD card and put that into your computer. If your laptop doesn't have an SD card slot like this, you would need an SD card reader, or you could connect your camera with a USB cable and use the camera itself as an SD card reader. All right, now we'll head over to the computer. Okay, I've connected my SD card here. It's untitled, and opened it up and navigated in the folder structure to where the start of my lights range was, which was 1649. So there's that picture. You can see the one right before it was a dark from the previous session. And then if you remember, the end of our lights range was 1715 right here. It's okay to include this frame where the trees are just coming into the corner, because that shadow area will be rejected by the rejection algorithm since we're using dozens and dozens of pictures. But I wouldn't want to include too many pictures like this, because then you can actually start seeing some effect in the stack if you have too much of this kind of thing. So I'm going from 1649 to 1715. So to select all of those pictures, I'll just click on one end of the range and then shift click on the other end of the range. And then you can see I have all of them selected here. And then I want to transfer them to my computer. So I'll just make a new folder. I'll just make it on my desktop here for convenience. I'll call it Blue Horsehead. And inside that folder, I'm going to make 4 subfolders. One called Lights, which we're transferring right now. That just means your photos of the night sky. And then the 3 calibration frames, darks, flats, and bias frames. But in Siril's script, you want to call this folder biases. And this is what you want, this structure right here. You want the name of your object, and then within that folder, you want these 4 folders, biases, darks, flats, and lights. That's what the Siril script that we're going to be using expects. Okay, and then inside of each of these folders, we just want to transfer all of our raw frames taken with the DSLR or the Astro camera. So I'll just copy those over just by dragging. You could also use Control-C, Control-V on Windows or Command-C, Command-V on Mac. It does the exact same thing as dragging. Okay, and then the next calibration frame I took was darks, and that range was from 1751 to 1770. Of course, these numbers would be different for your camera. And then I'm just going to drag those into the darks folder. I took 20. 20 is sort of my go-to number for darks, flats. It works pretty well. Same thing with the flats here. So those are the next ones I took. There's an example flat. You can see it looks pretty good. No lines or anything through it. We're also not really seeing any dust spots, but they are probably there. It's just that the way this is auto stretched on the computer, it's not showing them, but there probably are actually dust spots there. Okay, so then I'll transfer my flat frames. Okay, and in my case, I'd taken bias frames for a previous project, so I didn't retake them. But you can always reuse bias frames because they don't change that much. So they're not temperature dependent like the darks. So as long as you're sure your bias frames are good from a previous project, there's no reason to retake them. So I'm just going to copy them here from a previous project into this bias folder. Okay, with that done, if we look at the size of the folder of just our raw data, it's about 5 gigabytes. And if I look at the free space on my SSD that's inside my computer, it has about 221 gigabytes free, which should be plenty for stacking. Generally, a good rule of thumb with Siril, if you just use the defaults, is it'll take up about 4 to 5 times as much space as your raw data to do all the stacking process. Now, if you don't have that much free space, you have 2 options. One is in the preferences for Siril, you can turn on the symbolic links option, and this will not copy images as it's working, which saves on a lot of disk space. However, there are some limitations, especially if you're working in Windows, so you can read about them on the Siril website if you need this option. The other option, which I often use, is to just attach a external SSD when I'm working. And I found that in terms of speed, this only slows down the process slightly if it's an external SSD. If it's a spinning hard disk drive, this will really slow down stacking, so I don't suggest it. But if you have an external SSD with a lot more free space, like this one has 2 terabytes available, you could put this whole folder onto the SSD and choose that as your working directory in Siril, and it will really speed things up. But for today, we won't be using that, and we're also not going to use symbolic links. So I just wanted to give you those options if you're someone who doesn't have a lot of free space to work on your computer. Okay, let's go ahead and open up Siril. Here it is. I'm on the latest version, 1.4.0 beta 2, which was released a couple months ago as of July 2025. And the first 2 steps in stacking one-shot color data, or stacking any data, is highlighted with these blue buttons up here at the top. So we'll start by changing our current working directory. And if you're unsure about what your current working directory is, you can see it's right here in the middle. So the default on Mac is in my user directory, which is just called Nico. It defaults to the pictures folder, which is fine. But that's not where I have my data. So I'm going to change this. I'm going to click on this little blue home icon. And over here on the side, click on desktop, and then click on this blue horsehead folder, as that's where I have those 4 subfolders: lights, darks, flats, and biases. So that is my working directory. Okay, you don't want to click into this folder. You just want to click on the main folder with your object name and then click open. And after you do that, you'll see up here in the top center, it does update with your current working directory. So for me, that's desktop blue horsehead. And then right to the left of that, you'll see that there's this other blue button called scripts, and that's the next button we're going to press. So you click on that, go down to Siril script files, and there's some different options here. If we had been guiding and dithering, which are some semi-advanced options, but a lot of you that might apply to. If you were using auto guiding and you dithered between your lights, you might want to choose this file, OSC preprocessing Bayer drizzle, which should give you some advantages if you're undersampled to image sharpness. If all that doesn't make any sense, don't worry about it. For everyone else, if you didn't guide and dither, we're going to go with this file for a reflection nebula, OSC preprocessing. These other one-shot color scripts, OSC extract HA and OSC extract HAO3, only apply if you're using narrowband filters. So for reflection nebulae, we would never want to use a narrowband filter, and so we didn't use them. And so this is the correct script, OSC preprocessing. And as soon as you click on it, Siril goes to your working directory, which we defined first, and it looks for those 4 folders, and it immediately starts running that script. And you can see the progress over here on the console on the right. If this console stops and gives you an error, it's probably that you didn't set the working directory, or inside your working directory, you didn't have the 4 folders like it expected: biases, darks, flats, lights. So those are the things to check for. If you get some kind of other error, you might just have to Google what that error means. But those are the really common errors, is not setting your working directory or not making the 4 subfolders that the script expects. But what this is doing now is it goes through all of what we call pre-processing. So this is calibration. So that's using our flats, our darks, and our biases to calibrate our lights. Registration, which is aligning all of your calibrated lights to the same file. So it basically is aligning all of your images based on their star patterns. And this is where it's important to have in focus round stars, because the registration process relies on having in focus round stars to work correctly. And then finally stacking, which it's on to now, which is taking all of your registered lights and putting them down into one picture. So that's the process of improving signal to noise ratio by making a master of everything that you captured. Now, this process, if you're on a newer computer, like I'm on an M3 Macintosh with an SSD drive, should go pretty fast in Siril. It's one of the faster pre-processing applications. So for me, the script just completely finished while I was talking. So the total time it took was 1 minute, 40 seconds. Once it's finished, you can then open the resulting file, and it will say result, and then the total number of seconds represented by that integration. So in my case, it's 2,882 seconds. which would be a little bit under an hour, 48 minutes, which probably for the blue horsehead is not really enough. You'd really want more than that. But for the purpose of this tutorial, it's fine if our image is a little bit noisy and underdeveloped. Okay, so we've opened that file. Let me just show you that one more time. So we clicked open, it goes to our working directory. We want to find this thing called result.fit and click open. It opens here, and as you can see, the image is mostly black with just a few white star cores, and that is perfectly normal because we're in the linear view mode, which is down here at the bottom, or they call it the display mode. And if you click on where it says linear down here at the bottom center, you'll see that you have 7 or 8 different options there. But the one that is most commonly used as you're working is the auto stretch. So I'm just going to click auto stretch. All right, and now we can see our blue horsehead. Isn't that cool? It is upside down, but I usually don't fix the rotation till later. This is actually the correct orientation from the northern hemisphere. If we were just looking up at it in the sky, this is how it would look upside down. But to get the whole horsehead effect, we usually rotate it 180 degrees. Anyways, this is what you'll see, hopefully, when you turn on the auto stretch. You'll see lots of stars and your object, and also probably some kind of gradient. Unless you shot the object really high in the sky where there is no sky gradient. But this I shot quite low in the sky, so you can see there is a fairly significant gradient, which is brightest in this bottom left-hand corner, and the sky is darkest in the upper right-hand corner. Okay, so what do we do about that gradient? Well, this is a step where you can use Siril's built-in tools of background extraction. And I've shown this in several videos. Basically, you just select some samples here on the image just by clicking, and mess around with these parameters. So I'm going to turn up smoothing because this is a fairly normal gradient. There's not a lot of complexity to it, so we don't need to have a very unsmooth gradient correction. We want a very smooth gradient correction. So I would turn up smoothing and then click compute background. Okay, and you can see that worked pretty well at removing that gradient in the image. So for a lot of images, this built-in background extraction is perfectly good, and you can always try deleting samples by right-clicking on them and placing them in different spots in the image. I want to show you another tool, so I'm going to close this, which is GraXpert interface. So this is also under image processing. Now, if you haven't downloaded GraXpert and installed it this way, you won't see this, but this is an AI background extraction tool. And I should have shown it. I'll open that back up. The first thing you'll get when you open this up within Siril is a deprecation notice, because they're going to change how the Siril GraXpert connection works and put it as part of a script fairly soon. So for right now, we could run GraXpert background extraction right within Siril, but in the future, it's going to be a script. In any case, what I'm going to do is actually just open up GraXpert standalone. So this is, again, a free program you can download online. It's noting that I have a beta release that I got off the GitHub. That's fine. Okay, and then I'm going to load that result that we created right here into GraXpert just to show you this interface. Okay, it looks like this. It's a little bit of a darker stretch than we had in Siril. I would show you how to mess around with the stretch down here, but in my beta version, this sometimes freezes up the program, so I'm going to avoid that. But I'm just going to go right on here to background extraction, and the default smoothing is 0.5 with the AI model. I'm going to turn it up to 0.8 because, like I said, that was a fairly uncomplicated gradient. And there's a lot of dust in this region, so I don't want it to get confused and over-extract on the dust. Okay, and I'm going to go ahead and save that result, not as an XISF file, that's for PixInsight, but as a 32-bit FITS file. FITS is the more standard interoperable astronomy file that works with Siril, GraXpert, PixInsight, lots of different programs. Okay, and I'll click Save Selected, and it will ask me where I want to save it. I'll save it right back to our working directory. Okay, and then if we open up that result in Siril, let's take a look at what it looks like. Okay, and it looks like that. And I don't know. I'm not sure if I actually... that looks like it may be over-extracted around the nose of the horse head a little bit. There's also this very visible line down here, this black line. I'm not sure what that is. I think that must be because of some kind of tracking error or something. So we'll probably want to crop that out. But in terms of the two results, I actually think that I liked my results just with the normal background extraction better, which again, I just did by clicking on some samples here in the corners and on the sides, and one near the center, and clicking compute background with a fairly high smoothing. Yeah, I like that better. So it looks less over extracted to me. So the point of all of this, hopefully I'm not confusing you, is that there's different options for background extraction, and sometimes an AI model, especially with a dusty field like this, may not be the best choice. Sometimes the older, more manual way of doing it might be better. Okay, so I'm going to go ahead and click Apply. And because I don't want to get confused with this black line later on, I'm going to go ahead and crop that out of the image. So to crop in Siril, you just click and drag. And I'll just drag so that we're just cropping out that black line, but I'm getting as much of the rest of the image as possible. And actually, I'll bring in the sides just a little bit, because usually there's a little bit of stacking noise on the sides, a little bit of artifacts from the stacking process. All right, and I like that. That crop box looks good to me. So then I'm going to just go ahead and right click and choose crop. And you'll see that you also have the option to rotate and crop here, but I don't need any rotation. We've already sort of fixed the rotation how we want when we shot the object. So that looks good. I'll go ahead and click crop. And then we just got rid of that black line, which was a little distracting. The next step is usually just to go into color calibration. But I do want to show you an option for something called deconvolution. And there was an option for that in GraXpert, you may have noticed. And in my Pinwheel Galaxy tutorial, I used this deconvolution with the object only setting. And many of you asked, well, why didn't I also deconvolve the stars? And my answer in the comments to that video was because I don't like the look of how GraXpert does deconvolution on the stars. Since then, I've done some testing and found that Seti Astro's Cosmic Clarity now has a color version, and I do like how Seti Astro's tool does deconvolution of the stars. So let me show you that real quick. So I'm going to save this, what we've done so far, by going over here, not to save, but to the button right next to it, which is the Save As. Let me zoom in on that so you can see. This little button right here is the Save As, this little down arrow. And I'll save this as blue horse underscore BGE for background extraction .fit. And we do want to save as a fit file, and click Save. These default options, 32-bit floating point, are correct, and click Save. And it's warning us that the viewer mode is not currently linear. That's fine. We know that. Click Save anyway. Okay, and then I can go ahead and hide Siril. And I'm going to open up a new window, go here into my applications. Okay, and I'm going to go here to my Cosmic Clarity suite that I've just downloaded and unzipped from Seti Astro's website. And inside there, inside that folder, is an input and output file for running Cosmic Clarity. And so I'm going to put my Blue Horse bge.fit in the input file. And then I'm going to go down here and run Seti Astro Cosmic Clarity Mac just by double clicking it. And you can see it's a Python script, so it will pull up a terminal window and run. Okay, and it took a few minutes, but it's given me some options here for the Cosmic Clarity Sharpening Tool version 6.5. And I've found that the defaults work quite well, so I'm just going to use all of the defaults here. So yes to GPU acceleration, sharpening mode both, auto detect PSF, stellar amount 0.5, non-stellar amount 0.5, sharpen RGB channels separately, no. And just go ahead and click OK. And again, this is a newer version that works on color images that he just released recently. And then you can see you do get some nice progress report here. So it's now doing the stellar sharpening. Okay, and it took a few minutes, and now the process is completed. So now if we look in our output folder, you can see there's a new file in there with the same name we had given it, but now it has underscore sharpened. And so in Siril now, here's our original image, and let's go ahead and just open up that new image that was created. Here in the Cosmic Clarity folder. And hopefully you could see an immediate difference. The stars got a lot sharper. And it also probably is a harder difference to see, but it proved the sharpness of some of the nebula features as well. Maybe I could put up a quick comparison in the edited video here just to show you some of the differences. I really like how this looks. The GraXpert version of deconvolution, I like what it does to the object, but I don't like the star deconvolution. While with Seti Astro's tool, I think they both look quite good and typically improve the image. So I do recommend it if you can get it working on your system. Okay, next up, this image to me doesn't look like it needs much color correction. It looks really good since I shot it from a dark site on a moonless night with a stock DSLR, but just to make sure we could run some color correction. So first, we want to plate solve the image, which starting in Siril version 1.4 is under Tools, Astrometry, Image Plate Solver. It did capture the focal length and pixel size from the raw metadata of my camera, but it doesn't know the coordinates. So we would just have to know the object identifier. And so in the case of Blue Horsehead, it's IC4592. So I'll just type that in up here. If you're not sure what the catalog ID for your object is, you can just Google it. So just Google Blue Horsehead Nebula, look at some results, and you'll find that the catalog number for it. Okay, but then that fills in our right ascension and declination. And again, this focal length and pixel size are correct for my system, but if you found they weren't, you could just type in values there for your camera and lens or your camera and telescope. Once the right ascension, declination, focal length, and pixel size are all typed in, you can click OK, and Siril will attempt to solve it using online catalog of stars and your actual star field, comparing them. And in my case, it did it very quickly. Okay, so we've image solved it. Now we can go to image processing, go to color calibration, and go to Spectrophotometric color calibration, which is again new in Siril 1.4. I'm going to choose a G2V star, meaning a white star, sort of most similar to our sun. So then that should give us something that is like our color vision, since our color vision is all based on the color of our sun. We have a one-shot color camera. These are previously filled in, but they don't, with Canon cameras, they don't have all the options, but this is close enough. So I'm going to pick some Canon cameras here. But in any case, if your camera sensor is included here, you'd of course want to pick your correct sensor. If you were using any filters, you can pick that here. Here we didn't use a filter. And so this all looks good. We're going to click OK. And it will run the Spectrophotometric color calibration, which looks at the stars in your images and then calibrates it based on your choice of white point reference. And this takes a little while because it downloads some information from the Gaia catalog, which is a huge catalog of stars and their photometry. And then it gives you these nice plots of what it did. So all these little purple points on the plots are stars within your image, and then it tried to fit them to a best fit for white balance. And so you can see they all do clump around these two lines. I'm going to go ahead and get rid of these plots. And like I said, I'll close this as well. Like I said, I really don't see much of a difference there. The picture straight out of camera was pretty well color calibrated, but this is always a good thing to do just to make sure, especially when working with a reflection nebula, a nice broadband scene like this, to make sure that you have accurate color. Next up, I'm going to go ahead and separate the stars from the rest of the image and then stretch the stars and the nebula separately. And this is done with a free program called StarNet V2. And I've shown in many videos how to install StarNet within Siril, and nothing has changed there. So I'll link some of those, but there's different instructions, whether you're using Mac or Windows, but basically they all involve first installing the command line version of StarNet, then going up here to the preferences, miscellaneous, and telling it where your StarNet executable is, and applying those changes. And then when you go to the image processing menu and go to star processing, you'll be able to click on StarNet star removal. And if StarNet is working and you've actually installed it correctly, you'll see this execute button is blue. When you haven't set up StarNet with Siril correctly, this execute button will be grayed out. Okay, and then the default options are pre-stretch linear image. We do want that, and generate star mask. We do want that. I'm also going to turn on recompose stars on completion, and this will bring up a separate window called the star recomposition window, which is a special feature in Siril that I'll explain here in a moment. But with these three boxes checked, we can click execute. And you can see now down here it says running StarNet. And right here, it says using MPS backend. That's something specific to the Apple M chip, where it uses the GPU processor. Okay, and now it's done. And you can see the image didn't change too much here. And that is perfectly normal because we still have the auto stretch on. But now we have this window here, star recomposition window, and it has two graphs and two sets of sliders. And the set of sliders on the left, called the background stretch parameters, is basically, you can think of as stretching your sky and your nebula. And the star stretch parameters is just stretching the stars. So the order that I work is from left to right. I first stretch the nebula and then I stretch the stars. And to do this accurately, we can first sample the background. So I'm going to go over here to the image and make a little preview box like this. Just click and drag a little green box like that on something that is just the sky background. So not on the nebula, not on dust or anything like that, just the sky background. And I'm going to click this little eyedropper. And this samples all of the pixel values within this box and then sets a value right here. And it's set it as 0.008 for my image. It'll be a very low value. This one is normalized from 0 to 1. So 0.008 means very, very dark. Once you've set that, you can turn off the auto stretch by just going here to linear. And now you can see why it's so dark. This is what the data actually looks like at this point, but we're about to stretch it for real. So this that we've been using, this auto stretch, is just a temporary view of the linear data. But now we're actually going to go from linear to nonlinear using this stretching box here. And you can think of this if you've used other tools like just a complicated curves transformation. Okay, and so I'm going to, for my first stretch here, we want a big stretch, so we're going to turn up the local stretch intensity to around 12, and then we're going to bring the stretch factor over until you start seeing the nebula. You might see some bright stars as well, that's fine. And then you want this histogram to have plenty of separation here from the left edge. Okay, so we've done that. We're going to go ahead and click Apply. Then the next thing I'm going to do is I'm going to take this black point slider down here at the bottom, and I'm going to bring the histogram, this peak right here. This is all the pixel values and their brightness. And I'm going to bring this peak so that the left edge of it comes back closer to the left edge of the graph. So I'm going to take the black point and I'm going to bring it over until you see this left edge of this peak is over here, and then click Apply. And visually, you might not see much difference when you do this, but it's a good idea in terms to really get nice contrast in the image to do that step. Okay, and then this time I'm going to actually move my symmetry point. I'm going to move it to just a sort of general area of the nebula, something like that. And we'll sample that, and you can see that number got much bigger. It's now 0.11. And I'm also going to use a lower stretch intensity for this stretch. So I usually go somewhere between 3 and 4 for this second stretch. Remember, the first one was 12, so that was a much more dramatic move. Okay, and then you're just going to take this stretch factor, and this time I'm mostly just paying attention to the image. So what I'm looking for is to start bringing out some of the dimmer dust details. But you can also look at this histogram. And what I found is that you can see that there's these lines dividing the histogram. These represent every 10%, so from 0 to 100. And so I usually like the brighter part of the histogram to cross this 20% line on the second stretch with a nebula scene like this. And where it crosses is really sort of up to your taste. So you can see I can make the image much brighter, and it's now crossing right here at the 50% line in terms of the vertical height. And that can work. That looks pretty good. But typically, I like the option to stretch a little bit more later in the process with a curves transformation. So I usually don't stretch quite this far at this point. I usually am like this histogram mountain to cross this second line at around the 25% point, and the image then looks like this. And again, you can see some of the brighter stars are coming out, but that's normal. Don't worry about it if you see that. And then click Apply. Okay, so we've stretched the nebula how we wanted for now, but now let's stretch the stars. And for this, you don't need to mess with the symmetry point or the black point or any of these other things. I just use the stretch factor. And you can see that as you move that stretch factor over, it immediately updates with what the stars will look like. And if you're new to this, you might think, oh, well, that's enough. I can see some stars. But you really want to see them a little bit better than that, I think. I mean, of course, this is personal taste. But you can see, now we can see a lot more stars. So I'm going to go somewhere in between and something like that. You can, stretch everything a little bit more later. But this is a good opportunity to balance the stars with the nebula. So sometimes I'll go back and forth. So I'll bring up the stars and I'll be like, oh, that's actually the right level for the stars. But maybe now I actually want to bring up the nebula a little bit more. So I'll apply that on the stars. But now I'll go back to the nebula, and I'm actually going to move my box to maybe a darker part of the nebula, use that as the symmetry point. And let's just try another stretch. Oop, way too much, right? Okay, so I'm going to back off a little bit. But I think I like that. Okay, so just a very subtle stretch. And you can play around with both the stretch intensity and the stretch factor here. Okay, so we've gotten the picture to a basic level. If you wanted to just stay in Siril and just finish it here in Siril, the two things that I would do probably are under image processing, geometry, let's rotate it 90 degrees clockwise twice so that it's like this, right? So now that's the more classic view for the horse head. And then the second thing I would do is I would apply some saturation. So under image processing, color saturation, it gives me some warning about some low pixel values. You can just say rescale all values that are below 0. That's fine. Okay, and then I would just apply the color saturation all the way over, amount 1.0, and I might do that a couple times. But that second time, maybe the full amount is a little bit too much, so I would maybe back off just a little bit to, let's say, 0.5. And now that I'm seeing it like this, I think that it just looks a little bit too dark. And so I'm going to go to Stretches, Curves Transformation. And I'm going to put a point in this curve, and I'm going to bring it way up there in the middle, and then add a little bit more contrast and brightness to our image. And if you saw any kind of color imbalance you didn't like here, you could also go into the individual color curves and play around with those as well. So let me just first apply this overall color curve. Okay, but now I could maybe turn off the red and the blue color curve and just bring down the green if I thought that there was a little bit too much green noise in the image, which I did. So I'm going to go ahead and apply that. So now we're definitely well within our way. This looks pretty nice. We could call it a day here and just save out of Siril. So we can just go up here to the Save As, and you can pick any kind of image file. So I could pick a JPEG and call this Blue Horse Final Siril and save it like that. Okay, and if you're happy with that, that's where you could stop the tutorial right there. I often finish my final little color tweaks and curves tweaks with the GNU image manipulation program, just because I like working with layers and adjustments that way. So I'm going to undo those final saturation moves that we made. And so it's back to looking like this, and save it as a TIFF file. So we can bring it into GNU image manipulation program. Actually, GNU image manipulation program also can work with FITS files, but sometimes TIFF will work a little bit better. So let's save this as bluehorse.tiff. And 32-bit or 16-bit should both work fine. If you're going into Photoshop rather than GNU image manipulation program, I would suggest 16-bit, but GNU image manipulation program seems to work fine with 32-bit. So we'll do that and open it up. And we'll open that file that we just saved, which is in the desktop, bluehorse.tiff. And it will give you some warning about color profiles. You can just say convert. The first thing I usually do is I get rid of this yellow dotted line, just because I find it distracting. So I go to View and turn off Show Layer Boundary. And what I like about the application of saturation in the GNU image manipulation program is instead of just applying it globally, I can apply it to certain colors. So I can go up here to the colors menu and go to hue-saturation, and we can just click on blue, for instance, and increase the blue saturation and do the same thing with cyan and so forth. And this just gives you a little bit more control over how you're applying the saturation. Just like with Siril, you might have to apply it a few times to get to your desired effect. And so I'm applying it to blue, cyan, and yellow. And I'm liking how that's looking. It's a little bit harder to see because we haven't done the curves transformation yet, but I think that is looking good. The other thing I really like about this version of the GNU image manipulation program 3.0 is that they've added this layer effects option. So whenever you add something here from the colors menu, or at least with most of them, they'll add down here to the layer effects, and I can turn them off and on to see if I like what I just did, or delete them, or even double click and go back into them and change them. And you can continue doing that after you keep adding more layer effects. So that flexibility when I'm doing these final touches on an image is important to me. It might not be important to you, but for me, that's why I like finishing here. So, and then I'm going to bring up curves, and I'm just going to add a little bit of overall darkness, just changing what's called the black level by taking this point on the far left and bringing it to the edge of the histogram here. And then I'm going to add a little S-curve. So I'm going to make another point just off to the right of that and bring it down a little bit, and then make another point like that and bring it up a bit. And then I might do that one more time, but using slightly different points. So I'm going to go back to curves, and I'm again going to do another subtle S-curve like that. Okay, one more thing I want to talk about that you can do in here that I don't think you can really do easily in Siril is I saturated the yellows in the image twice. And I like what it did to the stars, but down here in the dust down here, I think that dust looks a little bit too yellow now. So let me get rid of that second hue/saturation by just deleting the filter. Okay. And so now the image looks a lot duller, but the dust around the nebula is more subtly gray. And what I could do is I can make a selection. Okay, and I'm going to choose this Select by Color tool. I'm going to go down here to where it says Select By, and I'm going to choose Lightness. And I'm going to zoom in just by hitting plus. And I'm going to pick some values. Okay, and it makes sort of a mess of values there, but what I picked was just a sky value, so something quite dark. And then I'm going to go to Select Invert. So now it's picking more the nebula and the stars. And then finally, I'll go to Select Toggle Quick Mask. Okay, and with this quick mask, I can see what's selected, and with what's selected, I can see it's more the brighter stars and the brighter parts of the nebula, which is exactly what I want. Okay, and then I can toggle that back off now that I've seen what I've done. Just to show you how easy it is to alter selections. Let's say I wanted to capture the whole nebula. I could just go in here into the select menu and do grow by 10 pixels. And now we have the whole nebula selected. That's maybe not what I want to do this time. So I'm going to undo that. But let's say I wanted to just sort of round out my selections a little bit. I could do grow by 1 pixel and then select feather and feather by 2 pixels. Okay, now if we look at the quick mask again, you can see that we now have sort of a rounder edges and a little bit more selected. Everything that's in this red is what's not selected, and everything that's not red is what is selected. Okay, I'll toggle that off one more time. Okay, and the point of all of this is now if I apply some kind of saturation adjustment, so I'm going to go back here to colors, go to hue-saturation, and I'll apply my extra yellow and cyan and blue. It's only applying to our selection. Okay, and so we've just made this new hue-saturation adjustment here. You can see it appears right there, but it's only applied to the selection. So now let's see what it did. So let's go select none to turn off the selection. Oh, and I can already tell I like this. And so I can turn off and on that selection, and that's exactly what I wanted. It's only applying that extra saturation to the brighter parts of the nebula and to the brighter stars, and not elsewhere in the image. So instead of applying that adjustment globally, it's applying it just to what we had selected. Okay, and then one little tiny thing I'm going to do here at the very end is just the color balance just looks a little bit too on the yellow-green side overall to me, and it's maybe because of what I was doing with color saturation. But in any case, I'm going to go to curves one more time. And this time where it says channel, the normal thing is when you do this, it's just applying to all the values. So red, green, and blue. But what I'm going to do is I'm going to change that to just green. So now it's only working on the green pixels. And I'm just going to slightly change the color balance by just taking down the green right here in the middle, just slightly below the baseline. And now to my eye, maybe I'll just move this just slightly down and right there. To my eye, that now looks more correct. But that's just a very little tweak there at the end. But it's again a reason I like working in GNU Image Manipulation Program is I can go here and I can turn that off and on and see exactly what it did. And it gave the overall picture a little bit more of a magenta tone rather than a green tone. But now that I'm completely happy with this, I can go to File, Export, or Export As, and we will just rename the end here bluehorse.jpg and export it. And because it's a JPEG, it gives me a bunch of options in terms of quality and so forth, but we can just leave all of those at 100%, and that's good, and click export. I'll just show you both finals here. There's my final with Siril, and I think I should have done a little bit more work with curves to darken the background, because you can see my final with GNU Image Manipulation Program definitely looks more finished. I darkened the background more and did quite a bit more with fine-tuning how that saturation was delivered. So hopefully you can see actually the advantage to using GNU Image Manipulation Program for some of those things. The other thing you'll see here with just applying saturation overall is the chromatic aberration from the lens that I was using, the 200 millimeter, really comes out. There's so many red halos around stars. By fine-tuning the saturation just where I wanted it, that all that chromatic aberration isn't super apparent in this final version. You're now seeing the names of everyone who supports me on patreon.com/nebulaphotos. And I'm doing something new on Patreon, which is a bonus video every month. So the bonus video this month, in July 2025, is going to be this same tutorial, but instead of with free software, I'm going to be using PixInsight and Russ Croman's tools, which are all paid tools, but you can see with this same data set doing it with another popular software tool. So that's what I'm going to be doing over on Patreon. But of course, there are many other benefits other than monthly bonus videos. There's also a monthly Zoom call with the entire community. There's a community Discord, which is a messaging application, and lots of other cool stuff. So if you're interested, check out patreon.com/nebulaphotos. Till next time, this has been Nico Carver. Clear skies.